Hey guys, today I'm going to teach you a case study on Matplotlib and Seaborn. So let's see how Matplotlib and Seaborn works. So I'm going to take a Titanic data set from Kaggle. So let me explain the famous Titanic data set. So we have a description here. So on the Titanic data set, so the sinking of the Titanic is one of the most infamous shipwrecks in history. So on April 15, 1912, during her maiden voyage, the widely considered unsinkable RMS Titanic sank after colliding with the iceberg. Unfortunately, there weren't enough lifeboats for everyone on board, resulting in a death of 15 or 2 out of 2 to 4 passengers and crew. While there was some element of luck involved in surviving, it seems some groups of people were more lucky to survive than others. So the variable nodes here. So let me import Titanic dataset first. Before importing, let me import basic library that are required for performing the data visualization. So let me import NumPy as NP. Import, let me import pandas. Let me import Matplotlib. So NumPy we are importing for array operation related operation. So we are importing NumPy for our related operations, and we are importing pandas for working on data frames. And Matplotlib is used for data visualization, and for our Seaborn is used for higher level data visualization like a category local plot and distribution plot. So let me load Titanic data set. So there is a Titanic data set that is available in the Seaborn library. So I'm going to load that data set that is available in the Seaborn library. So it's okay, it's not load data set. So it's load data set. So I have loaded the data set from the Seaborn library. So this is the data frame that is available. So let me see the first four rows of the data frame. So these are the first 5 rows of the data frame. So we have survived column. P class is a passenger class, sex and age and sibling, SP sibling and spouse. So let me go with the variable nodes. P class is approximately a proxy for socioeconomic status. First is upper, second is middle, and third is lower. So we have P class as 1, 2, 3 values, and we have age is fractional if less than 1. If age is estimated, it is form x 6.5. So we have age column over here, which is fractional. SIP spouse, the data sibling and spouse SIBSPs. The data set defines family relationship in the way sibling based brother, sister, stepbrother, stepsister, and spouse is husband, wife. So PARCH is parents and children. So the data defines family relationship in the way parent is mother, children is daughter, sons, stepdaughter, children could travel only with the nanny. Some children traveling only with the nanny, therefore parent children is zero for them. Okay. So this is the top 5 rows of our data set. Let's see Titanic.info. Let's see if there are null values in our data set. So if you can see here, there are some null values present in our age columns. Age column are not revealed. Some of the age is not revealed. Of passengers are not able to retrieve, and some of the age deck there is null values also present in the deck, and we have some null values in embark term, and we have various data types like integer, object, float, category, boolean. So let me see the 5 point summary now. 5 point summary is it can be find out by using describe function. So these are the 5 point summary: minimum, maximum, 25% of the minimum, 25 percentile of the value, 50% of the value is the median, and 75% of the value. And we have maximum, and we have also mean value, and also we have count value. Okay, so this describe function gives the statistical info for the numerical data only. You can see here we have survived P class age, siblings, spouse, parents, children, fair. So here, whatever is numerical value like survived is integer, P class is integer, X is not there because it's not an integer value, it's an object. Age is floating point value, and siblings, spouse is integer, parents, children is integer, and we have fair as integer float point value. So we don't have these columns because these are categorical variables. Now let's do operations. Let's see. Let's plot heat map from this point. So let's plot a heat map. So we have SNS dot heat map function for the heat map of. So let's see what are the parameters that are present. So heat map has we have to pass the data here. So we have to pass data. So what we'll check, we'll pass Titanic dot is first we'll check before passing heat map. I want to check what are the null values. I mean, how many null values are there in each of the columns. So that this can be find out by function Titanic dot is null. So you can see we have got the Titanic dot is null, which are the null values present. So there is no null values here. So you can see they are true. So let's see the value counts of that. Value counts. So we are getting Titanic dot. So this should be Titanic dot is null. Let me see. Is null dot sum. Let's do the sum. Titanic dot is null dot sum. Okay. So we have got some H column has 176 null values, and we have deck column has 688 null values, and Embarkdown has two null values present. Let's plot these null values in heat map. Titanic dot what is that? Is null, comma. Let's see in a heat map. So you can see we can change this color by passing. So this is the C bar. This is, let me see what are the parameters that is present. So we have passed data that is Titanic dot is null. So we have C bar. C bar is set to true. So this is the right hand side. Whatever C bar is showing, this is the C bar. So it's zero values. You can see there are not many null values in present in our data set for other columns except the one with the deck and each column. So let's give some. Let's pass some parameter where I will change the color map. C map is color map. You can see in the parameters. Color map is usually you can web search regarding C map attribute C map colors in documentation Matplotlib. Okay, let me choose. It's not showing. Yeah, it's getting. Okay, so let's see color map values. So color map values is usually these values you can give where it is plasma, inferno, magma, and CVDs. Let me pass where it is from this. Okay, let me copy this and let me pass it over here. Color map is this. So okay, so our class has same. So these are the null values that are present in our data set. So we have some null values present in embark column and as well as embark term column. So now what we'll do, let's convert back, let's do some univariate analysis like count plot and distribution plot. Let's plot that. So univariate analysis. univariate analysis. So univariate analysis, this can be done by using count plots. Let's set the figure size, axis and figure. Figure, fig and axis is equal to. Okay, let's plot subplot for that. We'll draw subplots of, let's have see the parameters that are present. So number of rows is set to 1 and number of columns is set to 1. Let's change it to, now we want number of rows as let's say 2 and number of columns as 2. And let's there is a fixed size attribute as well. So we can set the fixed size attribute value to be 10 comma 10. Okay, so now let's plot count plot. SNS dot count plot. Count plot of let's plot count plot on the variable survived column. On survived column. Okay, survived is Putting on survived column, and we have to pass the data. Data is Titanic, and the axis we have to mention here. Axis is AX. Axis is A. So let's see the attribute here. Axis is AX, right? So AX is our axis. AX, okay. AX is our axis. So axis is AX of X, ES of 0, comma 0. Let's see the plot now. Okay, so we have got the count plot for surveyed column where we can see almost more than 500 people have died, and around more than around between 300 to 350 people have survived. Let's now plot count plot for each column as well. Let's see what's the each column. Each, okay. Let's copy this and change this to age. Uh, you can see here age is okay. Let me change it for 0. You can see here the age is a continuous distributed continuous value, so it's not better to draw age in this manner. We can instead go with the distribution plot for age column. Let me plot distribution plot. This can be done by plotting sns.dist plot of Titanic of age, comma x is equal to axis of 1, comma 0. Okay. Now what is this? Xes. So I have mentioned the axis. So now you can see the density function, how age is distributed. More of the people are between age groups between 18 and 40. More people lie in this group. Now let me see there is another fare. This is the price of the ticket. So let's see the fare price, how much it is for. Let's see, it's a fare, Titanic of fare. Let's see, 20. And let's pass fare over here. The price of the ticket. Its axis is 1 1. So what happened? We have to pass. Okay, so we have got the fare price of the ticket as well, and most of the price. Let me see what have I. This is dist plot. Sorry, this is not. So most of the price fall is in this range. It's between 0 and around 50 euros, 50 to 55 euros, somewhat here. Most price varies around that value. You can see here fare is around 7 euros, 71 euros, 23 euros, 30 euros. Okay. So now let's see how many survived. Okay, in this data set, let's do the value count. See Titanic dot value counts of survived column. Let's see how many survived and how many not survived. So we can see that 549 people not survived and 342 people survived. So let's do the count plot of only survived data. So SNS dot count plot of Titanic Titanic dot value counts of survived. You can see uh, you can see this is there are 342 people not survived and 449. Let me see what's the problem here. Okay, we have passed Titanic count plot of value counts. Okay, we passed instead the Titanic of survived dot dot value counts. Okay, so we are getting the same answers. 342 not survived and 5 the CO52 survived and 549 not survived. Let me see if any changes occur if I do go with the dot. It dot survived. You're getting the same value. Okay. So now what we'll do, now let's plot histogram for survived TITNIC Titanic dot survived dot histplot. So let's see how the histogram. So we can see here there are three around 342 and 549 people. And let's plot a bar chart for this. We can plot bar chart by Titanic dot survive dot plt dot pie. Okay, so we have our bar plot. Let's see. Okay, so no, this is not the way we plot this. We should be value counts. We have to do the value counts and then I'm going to plot it. Okay. So yeah, we can see here there are this is the plot for pie plot. Let's see what is the percentage of people actually survive, pass through point till two decimal point. Let's take the percentage. So you have 61% of the people not survived and 38.35% of the people survived. Now let's do exploratory data analysis on P class. So we have P class as passenger class. Let's take Titanic of P class dot counts. So we have first class people have in first class we have 216 members, and we have in second class around 184 people taken living, and in third class we have 491 passengers. So let's group the data based on P class, ATANIC, and let's see how many people actually survived. We have group by of let's do grouping based on P class and survived, and let's grouping based on E class, E class and survived, and let's see the result for survived column, how many survived, and let's value counts. So I can see that. So this is survived. Okay, what is it? Okay, we want only see Titanic group by, and we want only survived column. So where we getting go to times survived pass Titanic dot group by dot not value count, it's count. Okay, so now we have count values. So how many people survived? So you can see in first class we have 80 members died and 136 people survived. So this is huge percent. So we can see in first class how many percent of values survived, like 136 by 136 plus 80 into 100. So we have around 62.96 members survived in our first class, and we have around similarly we can find out for second and third class as well. Let me now do count plot for P class. So we have count plot P class now. Let's do count plot. Dot count plot of uh, class is P class and data is Titanic. NIC. And as you can see, these are the people that are survived. These are the people where we have contact. Let's take Q is equal to survived as well. U is equal to this is not so 5. Okay, now we have people with how many people, percentage of people, how many people survived in each of the class. So we have around 1 5. You can see in histogram kind of plot, we have got a plot of we have got the count plot for how many people survived or not survived. You can see most of the people survived in first class and very least number of people survived in the third class. So now let's do something. Let's do a point plot now. So using this, let's do in using categorical plot. Let's plot a point plot by passing point is equal to plot point kind is equal to point. Okay, so here is survived B class. Okay. Let's see. This is the y variable actually. Data B class nested component X is B class. Uh, control X. X is B class. Y is this. And Titanic. Invalid syntax. So what's the problem? Is you cannot pass values for both X and Y. This is actually categorical plot. Sorry, this categorical plot. So you can see we have around 62% of the values survived here, and around 43% of the values survived here, and here um, around 28%, 28.5% something. We can calculate by passing here values. Like let me pass here. So let's see how many people survived in the second class. So 87 divided by 87 plus 97, 97 into 100. So you can see we have 47% survived in this class. So we have around value around this 0.47. So you can see this plot. This plot is called by this is point plot. So you can give kind is equal to point. There are various value you can give for kind active parameter. The kind parameter can be swarm plot, strip plots, swarm box, violin box, and point bar and count. Now let's do a point plot by taking the third parameter as sex. So let's take this control hue is equal to sex variable. So we can see here what is the percentage of people. Let me see. Okay, what is the percent of people survived uh, in the kind plot with hue? This is not giving proper result. I don't know. It's giving like around 90% of the male, female, and around 90% of the females survived in P class, and around 90% survived in P class second female, and around 50% of the females survived in third class. That's huge number actually, considering other male, because male only few males survived, few percent of males survived. So now let's see, let's do group by based on P class, sex, and survived. So let's do group by. So Titanic dot group by. Let's do group by based on where is our data set, where is the data frame. Let's do group by P class. What's the passenger class and survived or not, and also what is the sex? Is a male or female? Group by of P class survived comma 6, and let's see survived cost dot count. Let's see the count of. Let's see what does this gives first. Control Z. So this gives it a level. So let me pass dot count. So this gives how many male and female survived from each of the class. So we have female 77 male not survived, and we have 91 female survived here, and we have a huge number of people. Yes, you can see here we have around 90, more than 90% of the people female survived in first column because only three female died. So that's a huge number. Even sex is one attribute that is can be considered as highly effective on the death ratio. So now what we'll do, let's plot a categorical plot, sns.cat plot, where X is P class and Y is survived. And we have to pass data is Titanic. You can see this is how it's we are getting. So what we have to do, we have to pass hue has sex. Let's pass third column, hue is equal to sex. So we are getting like this. Category plot is giving value like this. P class is this, and survived is this. We are getting some wrong value. So we have to plot bar plot. Okay, kind is equal to bar. So you can see here how the percentage of people survival is there. I mean, more percent of people survived are female in each of the class, and very few male survival happened. So now what we'll do, let's make, instead of hue, let's take column as text and see how it gets. So you can see in column, this is the survival rate of a male and this is the survival rate of a female. Now let's do age column analysis as well. Let's take a continuous variable age column analysis. So now let's do plotting of histogram on age column Titanic of age dot hist. So you can see this is the histogram. Let's pass bins, total number of bins to be 30. Okay, now we have bins as 30, and let's have density as 2. We are getting some values over here. Let's keep density instead. Density gives the percent, so we have how many percent of values. So more percent of people lie in this group, age group, between 20 and 30. I mean, between 2018 and 35. Let's pass now the color. Let's give the color to be orange. Okay, so we have changed the color, and also let's take the increase the figure size. We can do this by passing parameter fixed size is equal to 12 comma 6 maybe. Okay, so this is the fixed size we wanted. So now let's do a distribution plot for this. SNS.dist plot, dist plot of Titanic of what is each column. So we have this distribution. Let's make sure that let's remove this hist plot from here. So we are making hist is equal to false. Let's see if this works. Yeah, it's working. So okay, let's color this. Let's shade this region of this distribution. We can do this by plotting. Instead of cat plot, we can plot sns.kde plot. Okay. So then let's pass the same parameters, Titanic of age. Dot C, Titanic of age. Let's see what we will get. Okay, we'll get so this distribution plot. Let's use shade at parameter. Shade parameter is equal to true. Let's give it as true. Okay, you can see we can have shaded this region. So now what we will do, let's draw a categorical plot, sns.cat plot of let's have x variable as sex and y variable as age. X is sex and y is age. Data is Titanic. Data is Titanic. Okay, what's the problem here? TATNIC. Okay, so positional argument follows keyword argument. Okay, so this should be okay. This is we are getting some plot. Let's see what kind of plot is it. This is kind is what is kind? Kind is options are by strip. This is I guess it's a strip plot. Let's plot a box plot for this. Instead, kind we pass it as a box plot. So box plot gives the 5 point summary like minimum, maximum, Q1, Q2, Q3. This region is called blue region is called as interquartile range, and we this also similarly. And we have this median value. Median value gives the what age group the person lies. So we can see around 30 age, around 30, and here around 28. Female age group median is 28, and male age group median is 30. Let's see some other attributes. Let's pass now. Now let's pass P class here. Q has P class. In which class does the age group people stay usually? So you can see here, the more of the age group people of higher age group people usually go for first class, and lesser age group people go for second, and third class group goes for very few people. Like I mean, younger ones usually prefer three. So you can see the median value for male is around 25 for the first class, sorry, for third class, and around 30 for second class, and around 40 for first class. And there are some outliers that are present in our male section as well, in first, second, and third class. And we have very few outliers. There is only one outlier in female class, female passenger class second, and female in the passenger class third. Now let's take another variable. Let's make this hue instead of hue. Let's have a column instead. So let's have two columns instead of three columns. So now we have three columns for we have column for P class, Q two, P class one, P class two, P class three. Okay, now let's plot a swarm plot for this also. Let's plot a swarm plot. So we will take kind is equal to rm swarm, and let's plot swarm. Let's see what we'll get. So we get this kind of swarm plot. Let's make hue is equal to let's so we have sex and age as the uh, variables. So let's see hue as uh, let's take X as P class, so in which class they are present, and Y as H class. Let's plot this first. So we have getting this kind of plot. So let's pass now the H hue class to be sex now. So yeah, we have plotted this. So you can see uh, what are the age group of people and what age group people and what is the sex of the person and in which age he lies and in which class he is traveling, we can see here. So let me explain this point first, the one point. So let me take this orange point here. So I can see that this orange is a female and she is traveling in a second P class, passenger second passenger class, and her age is around 9 years. This is all about the case study that I wanted to discuss with you about Titanic dataset. You can study further if you wanted to study regarding this Titanic dataset visualization in Kaggle. You can search Kaggle and learn it. Hope you enjoyed the session. Thank you for attending the session. Goodbye. And also please share, like, and subscribe the channel.